Good evening. You're welcome to online tutorials with Fametanti the Schoolboy. Today we'll take a look at chemistry. This is 23rd, right?
Yes.
We are still on the topic chemical what? Combinations, right?
Yes.
Chemical combination. Okay, in last week we introduced the topic and we discussed moles, number of moles, the relationship between number of moles, reacting mass and molar mass, and we defined what molar mass is, and we went straight to calculations. So today we'll continue from where we stopped in the calculations and see how far we can go. Our reference book for today is still New School Chemistry for Senior Secondary Schools by Oseyo Ababio, as revised by L.E.S. Apanisi and Herbert Igwe, 2016 edition. So under this chemical combination, we are specifically treating stoichiometry of what? Reaction. Stoichiometry of reaction. That's what we are treating now under the topic chemical combination. Okay. We solved about how many examples that day? Call the last example we solved. Okay, 4. Okay. Because I don't want us to repeat what we've done in class. Okay, let's see what we have here. Okay, let's put down this question. The question says, in the industrial preparation of hydrogen, let me write it out. Excuse me. The question continues from here. Right, so put down this question. So I'll give you like 1 minute to do that so we can continue. Copy correctly. Okay. The question says, in the industrial preparation of hydrogen triosonitrate 5 acid, ammonia gas is burned in oxygen in the presence of a catalyst. According to the following equation, 4 moles of ammonia gas plus 5 moles of oxygen gas gives 4 moles of nitrogen 2 oxide and 6 moles of water steam. The question now says, if 260 cm3 of ammonia are burned completely, are you with me? Yeah. Are burned completely, what volume of A, oxygen is used up, B, nitrogen 2 oxide is what? Produced. Remember what we said about this, about stoichiometry of reaction. We try to compare the amount of the reactants that react to each other, and also how they also relate the relationship with the what? Products. Are we together? Now, here, if you look at this equation, 4 moles, the mole ratio of ammonia to oxygen to nitrogen 2 oxide to steam as follows: 4 is to what? 5. As 4 is to what? 6. These are for what? For ammonia. This is for what? Oxygen, nitrogen 2 oxide, and what? And water, steam. Now the question now says, if 260 cm3 of ammonia is burned completely, what volume of oxygen is what? Used up. Now look up. If you look at this, if you look at the ratio between ammonia and what? Oxygen. At any point in time, the ratio of ammonia the mole ratio of ammonia to that of oxygen will always be what? 4 is to what? 5. Are we together? So if you can reduce this to 1 mole and see how they relate to each other. Am I completing? We can reduce this whole thing to 1. Start with ammonia 1 mole and see what will happen. So to do that, we divide through by what? 4. Remember, this is mole ratio. I did not put mole here because there's mole here, there's mole here. It's just a ratio. I didn't put mole. But if you want to know exactly what will 1 mole of ammonia yield, so that means you have to divide through by what? 4. You have something like this. 1 is to what? 5 over what? 4, right? As what? 4 divided by 4 is what? 1. 6 divided by 4 is what? 6 over 4 is 3 over 2, right? So we have 3 over what? 2. So if you like pump how many millions of amount of what? Of what is it called? Ammonia. The amount it will react, the ratio of the mole of oxygen that will react to 1 mole of ammonia will what? 5 over what? 4. It cannot do what? Exceed that. But remember again, in this relationship, this moles is also taken as what? Volume. And for if the reactants and product are in gaseous form, this can also be regarded as what? 1 volume, because of say the volume. So this 1 mole can also be ratio can also be regarded as 1 volume, 5 over 4 volumes, or cm cube, 1 volume of nitrogen oxide, and 3 over 2 volume of what? Of steam. Because all the species, both the reactant and product, are in gaseous what? States. So that means 1 volume of this will react with what? 5 over 4 what? Volume of what? This. At any point in what? Time. Does it make sense? Yeah. Now let's go back to the question. It says, if 260 single of ammonia are burned completely, what volume of oxygen is what? Used up. Now, what do you think we can do here? We have already have these mole ratios like this. What do you think we can do here? Look at it critically. 1 volume of this react with what? 5 over 4 volume. Right? 1 is to 5 over what? 4. As 1 is to what? 3 over 2. And this 260 cm cube will be used born complete. They want to know the amount of oxygen that will what? Used up. So if 1 volume of, remember I said that this is can also be regarded as what? Volume. Or if you like, you can simply do 1 mole of this will yield what? We react with what? 5 over 4 mole of this. Therefore, 260 cube will react with what? The mole will still cancel mole. Are we together? Now, so that means we have to set a proportion here. So what do you think we can do here based on what we did in the last? Remember, this is not the first calculation we are doing here. So that's why I'm throwing the question back to you. What do you think we can do here? I need your own idea based on what we have done. This is not, we have established this topic. So what do you think we can do here? What do you think? We have like 1 minute. Tell me what you think we can do here. Think about it.
Think 1 volume of ammonia. 1 volume of ammonia. This is equal to 260 centimeter. Then 5 over 4 is equal to that one.
Let's hear what. Like just speak a layman. That's what I say.
1 mole of ammonia.
If you volume mole is okay. Just okay. 1 mole,
260 centimeter.
cm cube.
Cm cube. Then we now 5 over 4 of oxygen. We now look for the one that is used up, the volume that is used up, because they gave us the volume of ammonium that is burned completely. So we are now looking for the volume of oxygen. So we now cross multiply.
You are there, but so you missed something. Don't worry, let me help you. So, here, this is the mole ratio or the volume ratio. Any of them is okay. For ammonia, at any point in time, 1 mole of ammonia will react with what? 5/4 mole of what? Of what? Oxygen. Are we together? Then 260 cm³ of ammonia will now react with what? X. Is it clear? So X is now equal to what? We cross multiply. It's now equal to what? 260 cm³ times 5/4 what? Moles over what? 1 mole. So mole will cancel mole. We are left with what? 260 cm³ times 5/4. So we divide 2. 4 divide 260.
I think this 5 will come down, then 4 will be on top. I don't know.
5 will come down. Why will 5 come down? You can't multiply. 5 will not come down. Okay? 5 will not come down. See it now. This times this. This times this. This times this. So 5 will not come down. Okay? So if you divide 2, 4 divide 260, 2 divide 260 is 130. Therefore 4 divide 260 is what? 65. This is 65 what? cm³, right?
Yes.
So 65 times 5 is what? Fast. Don't punch calculator.
It's 325.
3 what?
25.
Are you sure? So 65 times 5 is what? 325 what?
Yes,
cm³. 325 cm³ of what? Of which gas is used up? Oxygen. Is used up. Because 5/4 mole of oxygen or volume of oxygen need to be used up for it to be able to completely burn 1 mole of volume of what? Or volume of what? Ammonia. So 260 completely burned will now use up what? That's why we got 325 cm³. Is it clear? Is it clear? So the answer is what? 3 what? 25 what? cm³. Now, the second question now says, okay, you want to write it down first? Okay. Done? So the second question says, what volume of nitrogen 2 oxide is produced? So before you can solve it, you have to still go back to the what? The equation, okay? From this equation, look up, from this equation, 1 mole of what? Nitrogen, or 1 volume of, ammonia, or 1 volume of ammonia will yield 1 mole or 1 volume of what? Nitrogen 2 oxide. So if 1 mole or 1 volume of this yield 1 volume of this, so 260 cm³ of this will yield what?
260.
Is it clear? So this one is simple. The answer is what?
260.
Because they are in ratio of 1:1. So if 1 cm³ or 1 volume yield 1 volume here, therefore 260 volume will yield what? 260 volume. Is it clear? So no need writing this one on the board. The answer is what? 260 what? cm³. 260 what? cm³. You can put it down. I can flip this question, right?
Yeah.
Okay. Okay, let's solve another question on this. Still on the topic, let's look at this question. This question are from New School Chemistry. When we are done with this, we'll see if we can pick questions from past questions, maybe another day or so. All right, put down this question. This market are not writing well. What's going on? All right, let's look at this question. The question says 20 cm cube of carbon dioxide are mixed and sparked with 200 cm cube of air containing 21% oxygen. If all the volumes are measured at STP, calculate the total volume of the resulting gases. Calculate the total volume of the resulting gases. Now, let's look at the question again. It says 20 cm cube of carbon dioxide are mixed and sparked with what? 200 cm cube of what? Air. So tell me your thoughts here. What do you think? Okay, sorry, I'm blocking your view. We have 1 minute to tell me what you think. Just look at the question. Tell me what you think about the question. 2 minutes. So what would the equation look like?
CO plus O2.
CO plus O2 will give you what?
CO2.
CO2. Balance it. Is it balanced? Balance it, let's see. We have 1 minute more.
You add 2 in the front of CO.
It becomes what?
2 CO2 plus O2.
2 CO2 again.
2 CO plus O2. Then and then 2 CO2.
Good. So remember, this is stoichiometry of reaction. The first thing is to establish a balanced chemical equation of the reaction. Very important. So let's go. This is the reaction between carbon 2 oxide and what? Oxygen. So we have carbon 2 oxide plus what? Oxygen will give me what?
CO2.
Carbon 4 oxide. This is 1, this is 1. This is 2, this is 2. So if you put 2 here and put 2 here, it becomes what? 2. Is it balanced now? Oxygen 4. It's balanced now. Everything here is what? Gas. Right? Now, we were told, look up. From this, we'll take this thing, we'll break this thing down before sparking and after what? Sparking. We are told that 20 cm cube of what? Carbon 2 oxide was mixed and sparked with 200 cm cube of air. Good. This is where the issue lies now. This air in question, the volume is 200 cm cube. But oxygen percentage there is only 21%. So how do we now find the volume of the oxygen that will react? The volume of oxygen is simply find 21% of what? 200 cm cube. Simple. Like 200. Without wasting time. 24. Okay. To let's find the volume of what? The volume of oxygen in what? 200 cm cube of what? Of what? Air is equal to what? 21 over what? 100 times what? 200 what? Cm cube, right? 21% over what? 100% times what? 200 what? Cm cube. Simply, this will cancel this, right? 20 will cancel 20. So we are left with 21 times 2 cm cube, right? Which is what? 42 cm cube. So of oxygen, not air. The air is 200 cm cube. But oxygen inside that air is what? 21 for 2 what? 21% of 200 cm, which is what? 42 what? Cm cube. Is it clear? Now we have established, we've calculated the volume of oxygen that will be sparked with this carbon 2 oxide. Now, having determined that, now let's go. Before sparking, remember the first to do is let's establish the mole ratio. Okay? The mole ratio is 2 is to what? 1 is to what? 2. 2 is to 1 is to what? 2. 2 moles of carbon 2 oxide, 1 mole of oxygen gas, and we hear 2 moles of what? Carbon 4 oxide. Or simply 2 volume of what? Carbon 2 oxide, 1 volume of what? Oxygen, and 2 volume of, we hear 2 volume of what? Carbon what? 4 oxide. That's the meaning. Now, let us now do the calculation. So let's go. Now, we are told that 20 cm cube of this was mixed and sparked with 42 cm cube. Hope you know now, 42 what? Cm cube. Now, if all the volume are measured, calculate the total volume of the resulting what? Gases. Look up. 2 mole, 2 volume of what? Of what? Carbon 2 oxide. React with what? So, if you like, come here and increase the volume of oxygen here to 1 million. The volume of oxygen that will react with this carbon 2 that will always be half of what? The volume of what? Carbon 2. Does it make sense? That is the meaning of this. If you like, spark 1,000 cm cube of what? Oxygen. The one that will react will always be half of that of what? Carbon 2 oxide. So we are given the volume of carbon 2 oxide to be 20 cm cube. If you like, put 1,000 cm cube of oxygen here. It's only what volume that will react with this. You don't understand what I said. You did not. I'm trying to explain this mole ratio, the volume ratio. At any point in time, in this reaction now, the volume of oxygen that will react with carbon 2 oxide must be half of that of carbon 2 oxide. We are told that the volume of carbon 2 oxide is what? 20 cm cube. What the volume of oxygen that was packed is what? 42 cm cube. That's what I'm saying. That if you like, put 1 million here. The volume that will actually react of oxygen that will actually react with carbon 2 oxide will be half of that of volume of carbon 2 oxide. So what should be here? What should react? 10 should react. So, but here, they give us 20 cm cube of what? Carbon 2 oxide, and sparked with 42 cm cube of what? Oxygen. The volume of oxygen that will react is 10 cm cube. What will be the remaining one that will be left out? The 2 will be left out unreacted. The one that was, if you spark it, the one that will react to form this product is 10 cm cube of what? Oxygen. Will react with 20 cm cube of what? Carbon 2 oxide. So the one that is remaining on top of it is 32 cm cube. Is residual. It's a residual gas. It not react. So that 32 cm cube will be there as what? Residual what? Gas. And they told us they asked us to calculate the total volume of the resulting gas. That's the one that we left. Now, the resulting gas there now is the one that is left from here. The one left from here, which is 32 cm cube. The one left, remember inside this place, there are other gases there that is not oxygen, remember? So if you subtract 42 cm cube from this 20 cm cube, the one that is remaining there is other gases. You add it up to 32 cm cube here. It will give you a figure. A product was formed, which is what? Carbon 4 oxide. And it's the same volume of carbon 2 oxide that will yield carbon 4 oxide. So that means you need to add 1 cm cube here. So we are adding 20 cm cube of look up. So we are adding 20 cm cube of carbon 4 oxide, 10 cm cube that remain here. Sorry, 32 cm cube that remain here from where? Oxygen, right? Yeah. Then plus the residual gas here. Just do 200 minus 42. What is the answer?
58.
200 minus 42 is what?
58.
It can be 58.
158.
158. So 200 minus 42 is 158. Then add 158 plus 32 is what? That's 190, right? Right?
Yeah, 190.
Then add 20 cm cube of carbon 4 oxide produced. What's the answer?
210.
2 what?
10.
So the volume of the resulting gases is what? This one and this one, they are gone already. 10 cm cube from oxygen and this 20 cm cube from carbon 2 oxide have been used up. The remaining oxygen here, which is 2, plus the residual gas here, which is 158. Then plus the carbon 4 oxide produced, which is what? 20 cm cube. So everything becomes what? 210 cm cube. So the volume of the resulting gases is what? 210 what? Cm cube. Does it make sense? Do I write it on the board again? Let me write it. Alright, so now, so what you do is that before sparking, see what happens. First of all, okay, let me do something here. Sorry, I need to clean this. This is the volume of what? Oxygen, right? Volume of what? Oxygen. Then what is the volume of the remaining gases in the air? volume of remaining what?
Gases in the 200 minus 42.
Gases in the what? Air is equal to what? 200 watts, cm cube minus what? 42 cm cube. Which is what? 158 watts cm cube. So the volume of the gases that remain when 42 cm cube was packed is what? 158 cm cube. Now, let us now set up the mole ratio. So here you have 2 for carbon 2 oxide is to what? 1 for oxygen, which is to what? 2 for what? Carbon 4 oxide produced. So before sparkling, before what? Sparkling. Remember I told you that this is a certain as saying volume, okay? So before sparkling, what is the volume of oxygen, carbon 4 oxide, carbon 2 oxide that was brought in for sparkling? 20 watts cm cube. True of us? 20 cm cube before sparking. Before sparking here, what was here? 42 watts. True of us from air, right? Are we together?
Yeah.
That is 42 cm cube of what? Oxygen. Then after sparking, sorry, before sparking, was there carbon 4 oxide before sparking? So here is what? 0 cm cube. Now, afterwards, sparking, see what happened. After sparking, this one here will be used up. Okay? This one here will be what? Used up. Okay? Okay?
Yeah.
No, so after sparking, nothing else will be here. It's used up already. But after sparking here, what will remain here? Huh? Okay, now let me do something. Let me make this clearer. Let me do it before, during, and after, okay? Before, during, here. What we do during sparking is still what? 20 watts cm cube, right? Then here, during sparking, what is going that will react? 10 watts cm cube. During the sparking, what will be produced here? Produce what? It's 20 now. Is what?
20.
Is what?
20.
Is what?
20 cm, thank you.
20 watts.
Cm, thank you.
20 cm watts cube. Now, after the sparking, what will remain? This will be 0. True of us?
Yeah.
This one, this is what? Will be what? 0 watts cm cube, right? Good. Now, this one, this is what? The one that remains here is what? 32 watts cm cube. Here,
20.
this will go the other way around because initially it was 0, but after this was formed. So what remains after is what? 20 watts cm cube. So after the sparking, what remains is what? 32 cm cube of what? Oxygen, 20 cm cube of what? Carbon 4 oxide. Then resulting gases will now become what? Volume of resulting what? Is now equal to what? Add up this one to the one that remain here, right? Is now equal to what? 32 cm cube plus 20 watts cm cube plus what? 158 watts cm cube. The answer is what? 210 watts cm cube. So the volume of the resulting gases is what? 210 watts cm cube. Any question here? Any question here? Any question here? Are you sure? Check well. Check well. So if no question, we'll go to the next. Just write it down, I'm coming. So let's solve one more question, then we may stop here for today. Okay? So fast, so we can solve this question. Fast, copy fast. You are done? So look at the question. Tell me what you think.
First thing is to write out the equation.
Okay, To do what?
Write down
The question, okay, so yeah, what is the question all about?
CaCO3.
Uh-huh.
When heated, will now give us CO2 and CaO.
And see what?
AO.
Okay, so what next?
Then the second thing is to balance the equation.
To do what?
Balance the equation.
Okay, balance it now.
It's balanced.
Is it balanced?
Yes, it's balanced.
So what next? What next? I agree with you, balance. What next? Just do a rundown of what the steps to take.
Calculate the volume of carbon
Hmm?
dioxide at 70% pressure, which could be obtained by heating. Then we have to calculate the volume. CO3 is equal to 1 mole of CO2. So
All right, you've tried. Let's solve this question so we don't waste time. Okay, solution. Now, as you say, you establish a balanced chemical equation of the what reaction. Let's go. We have CaO3 when heated, right?
yes,
Yield what?
CO,
Calcium oxide plus what?
CO2.
Carbon 4, this is gas. Calcium oxide is what? Solid, right? Is it solid?
Yeah.
So this what happens. So what are the mole ratio? 1 mole of this will give rise to what? 1 mole of this and what? 1 mole of this. 1 is to 1 is to 1. So 1 mole of calcium trihydrocarbonate 4 will give rise to 1 mole of calcium oxide and 1 mole of carbon 4 oxide. All together. But we are told that 10 gram of carbon 4 oxide was of this, sorry, of calcium carbonate was what? Heated. So 10 gram. But we have it in mole. So the best thing is to move this 10 gram to mole. So we can put it here and get the equivalent for what? Carbon 4 oxide. Simple. And get the answer. Now, remember what we said about the relationship between reacting mass and molar mass. Number of moles is equal to reacting mass over what? Molar mass. So if the reacting mass of carbon 4 and calcium carbonate is 10 gram, that means the number of moles of calcium carbonate that actually reacted will be now 10 gram divided by molar mass of what? Calcium carbonate. What is the molar mass of calcium carbonate? 100 gram per mole. So simply do 10 gram divided by 100 gram per mole, and you get 0.1 mole. So that means 0.1 mole of calcium tricarbonate 4. Since 1 mole of calcium tricarbonate 4 yield 1 mole of what? Carbon 4 oxide. Therefore, 0.1 mole of calcium tricarbonate 4 will also yield what? 0.1 mole of what? Carbon 4 oxide. Since you have now established the mole of carbon 4 oxide, what next are you going to do? The question says we should find the volume. There's already a relationship at STP that 1 mole of a gas at STP is 22.4 dm cube. So this at this standard condition, that means 1 mole of carbon 4 oxide is equal to 22.4 dm cube. Well, will occupy 22.4 dm cube. Therefore, 0.1 mole of carbon 4 oxide will now occupy what? If you cross multiply, you get 0.1 mole. Sorry, you get 2.24 dm cube. So the volume of carbon 4 oxide that is what? Liberated is what? 2.24 dm cube. Is it clear? Is it clear? Then if you want, you can move it to CMQ depending on your choice. So now let's now solve this. So we stopped here, right? So let's find the mole of what? We move this 10 gram to mole of calcium carbonate. Therefore, amount of what? Number of mole of calcium carbonate that what? Reacted is equal to what? Reacting mass. Are we together?
Yeah.
Over what? Molar what? Mass. What is the reacting mass?
10 grams.
From the equation. For the question, 10 grams over what? 100 grams per what? Mole. And this will give us what? 0.1 mole of calcium carbonate. So 0.1 mole of calcium carbonate reacted, right? 0.1 mole of calcium carbonate was reacted. But if you go to the mole ratio, 1 mole of calcium carbonate yield what? 1 mole of what? Carbon dioxide. Therefore, 0.1 mole of what? Calcium carbonate will yield what? 0.1 mole of what? Carbon dioxide. So the mole of carbon dioxide is 0.1 mole. But at STP, 1 mole of a gas occupies what? 22.4 watts dm cube. So the gas in question here is what? Carbon dioxide. Therefore, 0.1 mole of carbon dioxide will yield what? X. So X is now equal to what? 0.1 mole times what? 22.4 watts dm cube all over what? 1 mole. Mole will cancel mole. We are left with 22.4 dm cube times 0.1. There will be decimal movement because of 0.1. There will be decimal movement from here to where? Here. So the answer is now what? 2.24 watts dm cube. So 2.24 dm cube of what? Carbon dioxide will be what? Liberated. When 10 grams of calcium carbonate 4 is heated. So the answer is what? 2.24 dm cube. If you have any question, ask. I think we will stop here for today. If you have any question, please ask so I can answer. In the absence of any question, we'll call it a day. We'll stop here for today to see another day. No question. All right. So thank you very much for your attention. See you next time.